Hey everyone, welcome to This Explainer. Today we're tackling something that often trips up a lot of 11 and 12-year-old learners, but honestly, it really doesn't have to. We are talking about integers. Think of integers as an expansion pack to the whole and natural numbers you already know. They just stretch out infinitely in both directions. Now, math assessments on this topic can sometimes feel a bit like scary tests, but today we're going to reframe all of that. They aren't traps. They're really just logic puzzles with incredibly consistent rules just waiting to be cracked.
Okay, let's dive right in. We've got an actual Prep I end of topic assessment right here from the City School. We're going to completely conquer this exact paper today to show you that once you understand the rulebook, decoding the real number system is an absolute breeze.
So here's our game plan for today. First, comparing and ordering integers. Second, the rules for addition and subtraction. Then, multiplication and division. And finally, Section 4. We'll wrap it all up with BODMAS and some real-world temperature puzzles.
All right, Section 1, comparing and ordering integers, decoding size. Welcome to the negative dimension. It's kind of like a parallel universe where everything you thought you knew about size gets flipped upside down. We're starting with this question from the assessment. Which integer is the smallest, -5 or -12? Now your gut reaction might be screaming 12, right? Because in the regular numbers world, 12 is obviously bigger than 5. But here's the catch. In the negative world, a bigger digit actually means a smaller value. Think of it like riding an elevator down into a massive underground parking garage, or diving deep below sea level. If you're on floor -12, you are way further down, much lower, than if you were just on floor -5. So, because you're lower, -12 is mathematically the smaller integer.
Let's put that exact logic to the test with our next challenge. We need to arrange numbers like -3, 5, -8, 0, and 2 in ascending order. That means smallest to largest. So, using our underground elevator trick, the lowest floor is -8. Then we go up to -3, cross 0, up to +2, and finally +5. Make sense? And for descending order, largest to smallest, we'd start at the top floor, +7, and drop all the way down to the basement, hitting -9 at the very bottom.
Moving right along to Section 2, addition and subtraction rules, the clash of signs. So, what happens when we get a classic clash, like in this next question? We're trying to figure out -6 plus +4. You've got a negative and a positive colliding head-on. The answer? -2. It really helps to think of this as a massive tug of war. The negative team is pulling with a strength of 6, and the positive team is pulling with a strength of 4. The negatives are stronger, right? By exactly 2 points. So you just find the difference between the numbers, and the larger absolute value, which is the 6 here, wins the tug of war and gets to keep its sign. Let's lock those rules in with some more examples. If you're adding two negatives, say -8 plus -5, they're actually on the same team. No tug of war here. You just add them up and keep the sign. Boom, -13. But here's where it gets kind of wild. Subtracting a negative. Take 6 minus -9. When you subtract a negative, those two minus signs crash right into each other and actually form a plus. It literally just turns into 6 plus 9, giving us 15.
Okay, Section 3, multiplication and division, the double negative.
Now, you can completely forget that tug-of-war analogy for a second, because multiplication and division, they have their own super strict, highly predictable rulebook. Check out this rapid-fire question. What is -7 multiplied by -3? Take a second. Try to remember the rule in your head before I give it away. Got it? Well, this perfectly illustrates the golden rule for multiplying integers. If the signs are exactly the same, your result is always positive, period. So, -7 times -3, +21. Easy. We see this again with -9 times -4, which gives us a +36. But if the signs are different, like a +15 divided by a -5, the result is always negative. In that case, -3.
Let's reinforce that same signs equal positive rule with another really clean division example. -45 divided by -9. Again, two negatives make a positive. So that leaves us with a solid +5.
All right, the final stretch, Section 4, BODMAS and temperature, putting it all together.
We've mastered all the individual rules, so now it's time for the final boss level. We're jumping into the ultimate challenges that will test absolutely everything we've just learned.
This challenge demands we bring in BODMAS. We've got -5 plus -3 times 2. Now, BODMAS tells us that the order of operations is totally non-negotiable. Multiplication always happens before addition. So step 1, multiply -3 by +2. The signs are different, so that's a -6. Step 2, add that back to our starting number. We have -5 plus -6. Same team, so we just add them up, keep the sign, and we get -11.
And here is the ultimate payoff. This is exactly why learning these rules actually matters outside the classroom. Check this out. The temperature was -4 degrees Celsius. It then rose by 9 degrees Celsius. What's the new temperature? Think about the real-world logic here. Just picture a thermometer outside. You're starting below freezing at -4. The word rose means we're adding, right? We're moving up that number line by 9 units. Now it takes 4 of those degrees just to thaw out and hit 0. After that, you still have 5 degrees left over to keep warming up.
So as you break right through that 0 barrier, you land cleanly on a new, much warmer temperature of exactly 5 degrees Celsius. Boom, problem solved.
So the really crucial point I want you to take away from this is that integers are honestly just a game of logic. Once you map out that number line, realize that descending just means going deeper underground, and memorize how those positive and negative signs clash and combine, you completely master the rulebook. Absolutely anyone can conquer this puzzle.
Which leaves me with one final thought for you today. If you can confidently calculate a -4-degree freeze rising by 9 degrees to predict the weather, what other invisible, real-world math codes can you crack next? The whole mathematical universe is out there, just waiting for you. Thanks so much for joining me on this explainer, and keep conquering those puzzles.